Hi all, it's day 2 of the law of sines, and we're throwing in a triangle area formula today. The triangle area formula is only used when you have a side angle side setup. And so remember, a side angle side setup is going to have two sides and the angle is between them. So if you have your normal triangle where angle A and side A are opposite, angle B and side B are opposite, and angle C and side C are opposite, then if you are using angle A, then that means you have to use sides B and C because B and C make up A. If you're using angle B, you have to use sides A and C, and if you're using angle C, you have to use sides A and B. The area formula, if you want to memorize not 3 separate formulas, but just memorize this formula, is 1/2 times a side times another side times the sine of the angle between the two sides. Again, you use this formula when you don't have a right triangle. The 1/2 base times height is used when you have a right triangle. So let's draw this picture. We want to find the area of a triangular lot that has two sides that are 90 meters in length and 52 meters in length. And the included angle is 102. So here we have a side angle side setup. So our area is going to be 1/2 times one of the sides times another side times the sine of the angle between it. You're going to plug this into your calculator all at once. Don't do it step by step, and you should get 2,288.9 meters squared because it is area. On example 2, we have a parking lot that's in the shape of a parallelogram. Well, here's what a parallelogram looks like. And in this parallelogram, the length of two adjacent sides are 70 meters and 100 meters. We also know in a parallelogram that the opposite sides are congruent, and the angle between the two given sides, which are the 70 and the 100, is 70 degrees. So what we're going to have to do is we're going to have to make a triangle. So we need to draw our triangle so that it does not touch the given angle. We use these two sides and the angle between them to find the area. So it's going to be 1/2 times side times sine of the angle between them. That's the area of one triangle. And since this is a parallelogram, and a parallelogram has not only one triangle, but two triangles, we have to take this formula and double it. By doubling this formula, it's going to cancel out the 1/2. So when you take 70 times 100 times the sine of 70 degrees, make sure you're in degree mode, you get 6,577.8 meters squared. That's it for the area formula. You just have to remember that you have to use the angle between the two given sides that we're using. Now let's switch gears and let's go back to the law of sines and the ambiguous case. Remember, the ambiguous case you can only use when you have an angle side-side setup, which is the same thing as a side-side angle setup. You can only draw two triangles if you are given an angle that is acute. So in example number 1, angle B is an acute angle. So I'm going to draw this picture. And angle B, the given angle, I always put in the lower left-hand corner. Side B has to go across from it. And then the third piece of information will also be another side. I always put it on the left-hand side. Since that's side A, this is going to be angle A, making this angle C, which makes this side C. So I'm going to try to find the dimensions for my first triangle. I'm going to take 11.2 over the sine of 24 and set it equal to 13.4 over the sine of A. Remember, you got to cross multiply, and you're going to get the sine of A to equal 0.4866, and then you take the inverse sign of 0.4866 to find angle A. And we get angle A to be 29 degrees. I think I shut off my pen. 29 degrees. Okay. So then angle B for our first triangle will be 180 minus 24 minus 29. I don't know why I put a prime with that one. So I'm going to erase it and say angle B. I said angle B, but I wrote B prime. So I get angle B, which is, what is that, 127 degrees? Now I need to find, sorry guys, I'm losing my mind. That's angle C. We already had B. B was 24. So angle C, oh, this is not working for me today. Sorry about the technology hiccups and the fact that I can't look at letters and understand what I'm talking about. So I found angle A to be 29 degrees. I'm going to write that one in. I found angle C to be 127 degrees because the three angles in a triangle have to add up to 180. I am not going to write that in. So now the last thing that I need to find is side C in my first triangle. So to find side C, it's going to be C over the sine of 127 equals 11.2 over the sine of 24. Or I could do, that's a 24, or I could do 13.4 over the sine of 29. Both would work out. So I get that side to be 22. And since I rounded to the nearest tenth on the other sides, let's say 22.0. I don't have a calculator in front of me, so I'm just going based off of the work on my paper. So hopefully I'm rounding correctly. All right, since our given angle is acute, we have to now test to see if we can find a second triangle. To find a second triangle, we use the fact that this side that's opposite the given angle can be swung along the non-given side and create an isosceles triangle. That isosceles triangle is not my new triangle. My new triangle is the one that has the given side, the given angle, and the given side, because if this is isosceles, this side is also 11.2. Since this is isosceles, this angle right here is 29 degrees, which makes this angle here, which is my new angle A prime, 180 minus 29, which is 151 degrees. So that's angle A prime. Angle C prime is up here, and angle C prime is found by taking 180 minus 151 minus 24. And angle C prime ends up being, what do we have left here? 5 degrees. The biggest angle is opposite the biggest side so far, so I can proceed with this problem. Everything makes sense. So now the last thing to find is side C prime, which is down here at the bottom. So I'm going to do C prime over the sine of 5 equals 11.2 over the sine of 24. Or I could have done 13.4 over the sine of 151. When I cross multiply and solve here, I get C prime to equal 2.5. So as you can see, I was able to get two sets of answers, and I have to include both of those answers in my solution. In example 2, our given angle is an obtuse angle. This tells me already that if the given angle is an obtuse angle, I either have no triangle at all that exists or only one set of answers. The given angle is angle B. I put that in the lower left-hand corner. Side B was 23, and then the third piece of information is another side. Me personally, I always put that on the left. That side is A, so this is angle A, which makes this angle C and this side C. So I know that only one triangle exists here. So I'm going to do the law of sines and take 23 over the sine of 100 and set it equal to 15 over the sine of A. When I cross multiply, I am going to have to take the inverse sine because I'm looking for an angle, and angle A ends up being 40 degrees. When I add 40 and 100, I get 140. So 180 minus 140 gives me 40 degrees for angle C. Since those angles are both equal, I know this is an isosceles triangle, so I could just use my isosceles triangle rules to find side C, and I know that side C has to be 15. If I forget my rules for an isosceles triangle, then I would take side C over the sine of 40 and set it equal to 23 over the sine of 100, or 15 over the sine of 40. Both would work. On example 3, I know that this angle is 85 degrees, so I'm going to have to check for a second triangle here. So if I draw my picture, my given angle goes in the lower left-hand corner. That's A this time. So side A goes across from it. My other side is 25, and that goes across B, so this is C and angle C. So I'm going to set this up 15 over the sine of 85. Remember, the angle always goes with the sine, equals 25 over the sine of B. So as I'm working through this, I get the sine of B equals 1.66. So when I take the inverse sine of 1.66, I get an error. When you get an error on your calculator, that means that no triangle exists. The reason why no triangle exists is because sine or cosine, if you're working with cosine, those values can't go higher than 1, and 1.66 is bigger than 1. Last but not least is example 4. In example 4, we're going to put our 20.5 degree angle C over here in the lower left-hand corner. Draw this just to make it a little bit bigger. And side C has to go opposite it. The third part, which is another side, goes on the left, and that would be angle B, which makes this angle A, and down here side A. Since our given angle is acute, we have to look for 2 sets of answers. Sometimes you get 2 sets, sometimes you don't. The first set of answers you get just from working through the law of sines. So it's going to be 12 over the sine of 20.5 equals 31 over the sine of B. We've done this enough where you guys can cross multiply. You can solve for B. Make sure you take the inverse sine, and you get B to equal 64.8 degrees. When you add up 20.5 and 64.8 and subtract from 180, you get angle A to equal 94.7 degrees. So don't forget your geometry rules. You can always use those. Last thing to find is side A. So you're going to do side A over the sine of 94.7 equals 12 over the sine of 20.5. Cross multiply and solve, and you get side A to be 34.2. I always stop right here and make sure everything makes sense. Is my biggest side opposite my biggest angle? My biggest side is A, it's opposite angle A, and my smallest side is 12, and it is opposite the smallest angle. So everything's working out and making sense. So I'm going to go ahead and check for a second triangle. With the second triangle, you always take the side that's opposite the given angle, and you swing it along the non-given side. So I'm going to swing it over to here to make an isosceles triangle. This is 12. We just found angle B to be 64.8. So that means this angle right here is 64.8. Remember, the new triangle is always the one that has the givens in it. So the 20.5 was given, the 31 was given, and then this given right here is 12. That means this is our new angle B, this is our new angle A, and then this side here is our new side A. I'm going to find B prime by using supplementary angles, and 180 minus 64.8 ends up being 115.2 degrees. Then angle A prime, I'm going to use the fact that triangles add up to 180, so I'm going to take 180 minus 20.5 minus 115, there's no decimal there, 0.2, and I'm going to get A prime to equal 44.3. Remember, if those angles go over 180, you stop the process and you cannot make a second triangle. So now side A prime at the bottom is opposite of the 44.3 that we just found, and then the 12 is opposite of the 20.5 that was given. So when you cross multiply, we get side A prime to be 23.9. Come get help if you need it.